Hi students, now we are going to discuss the variation of acceleration due to gravity with latitude. Now we have studied in geography that 0-degree latitude is called equator and 90-degree latitudes are called as what? The north and the south poles. Now say for example, a mass m is placed at a point P on the surface of the earth. If you join the position of this point P with the center of the earth O, then the radius vector OP makes an angle with the equator, that is lambda. This angle subtended by the radius vector of the point, okay, with respect to the equator, that angle only is called as the latitude. So in this picture, lambda is the latitude at the place or the point P where an object of mass m is placed. Now wherever the object is on the surface of the earth, its weight mg will always act towards the center of the earth vertically downwards. Is it not? So you can look at this object of mass m placed at P, its weight is mg. This mg is acting towards the center of the earth always. So this is its actual weight, and what is the acceleration due to gravity at that place we have to find out in terms of g. Okay. So normally its weight means m into g we take. But what is the actual value of acceleration due to gravity at this position, that is g dash, let us assume we are going to get an expression for g dash at the place P in terms of g. Okay. Okay, now you see here, this is the axis of rotation passing through the north and the south pole. Okay, so this is the north pole and this is the south pole. So the axis of rotation is having an angular velocity omega. So omega is the angular velocity of rotation of the earth. Okay, if you stand on the surface of the earth at point P, in 24 hours, when the earth rotates once, when the earth completes one rotation, this particle at P must have revolved in circular path, is it not? So as per the definition of rotational motion, each particle on the surface of this sphere must have exhibited circular motion. So this particle or this object of mass m is going through a circle and completes after 24 hours. Can you all see this red circle? Okay. So this circle is having a radius r dash. So the radius of this circle through which this mass m has gone through is denoted by r dash. And you get a right angle triangle. Let us take this point as C. So that OPC is right angled at the point C. If this angle is lambda, then this alternate angle made at P also is lambda. Is alternate angle. Is it not? So you see that the side PC is equal to r dash, which is the radius of the circle through which this particle of mass m is revolving. As a result, a centrifugal force will act on the particle. A centrifugal force, and this centrifugal force will be always acting away from the center, that is outwards. So you can see that this is the direction of the centrifugal force. So let us take this point as S. So the centrifugal force is acting towards S, that is along PS. And this force, centrifugal force, is equal to mass into centrifugal acceleration. Centrifugal acceleration. So this is equal to mass m omega square into r dash. We have derived this equation m v square by r, otherwise m omega square into r. So the centrifugal force acting on this object of mass m is equal to m into omega square into r dash. Okay. Now I will get the relationship between r dash and r, where r is the actual radius of the entire earth. Is it not? The earth is having a spherical shape and its radius is equal to what? R. That is, this radius is equal to r. So OP is equal to r. I am going to express r dash in terms of r. So you look at this triangle OPC. Okay, in triangle OPC, what is cos of the angle lambda? Cos lambda is equal to r dash by r. Therefore, r dash is equal to r into cos of lambda. So this is the required first step. I am expressing the radius of the circular path r dash in terms of the radius of the earth, capital R. So r dash is found to be equal to r times cos of lambda. So here I am going to substitute. Okay, here I am going to substitute. So this is a centrifugal force is equal to m omega square into r dash is what? R cos lambda. So this is r into cos of lambda. So in this term, omega square r cos lambda is a centrifugal acceleration. That is a centrifugal acceleration. In which direction it is acting is along PS. So I will write centrifugal. Okay, centrifugal acceleration. So A PS along this direction PS. How much it is equal to? Omega square r into cos lambda. Okay. Now I am going to find its component along the direction of radius like this. I will take another point Q. I will extend this radius. Actual centrifugal acceleration is what? Omega square into r into cos lambda, and that is acting along the direction P to S. But what will be its component along the direction PQ? So this angle is corresponding angle. Therefore, this must be what? Lambda. Is it not? So this acceleration PS is omega square into r cos lambda, and its component along. So acceleration along the direction PQ I want, PQ. So APQ I have to find out. So this must be equal to APS into cos of the angle lambda, cos lambda, because I am going to resolve. I have to resolve this, find the component of this acceleration along this direction PQ. So it must be APS into cos of this angle, is it not? So this is cos lambda, and this is equal to what is the centrifugal acceleration along the direction PS? That is omega square into r cos lambda. So omega square into r cos lambda multiplied by again cos lambda. So that this is equal to omega square r into cos square lambda. So this is the acceleration along the direction P towards Q, which is opposite to the direction PO, where G is acting. So my dear students, here you should be very careful in understanding where is the object placed actually. The object of mass m is placed at the point P. At that point, body is having acceleration due to gravity G from P towards O, and another acceleration is P towards S. So one acceleration is P towards O, the other acceleration is P towards S. So I resolve the component along direction PQ. Understand? So that APQ is APS into cos of lambda. Now there are two accelerations acting at this point P. One is small g towards the center along the radius. Okay, and APQ is away from the center of the earth, and along the radius, that is along the direction PQ. It is like a tug of war. Two teams are pulling a rope. One is towards the center of the earth, one is away from the center of the earth along the radius. So what will be the resultant acceleration is the question. Understand? So we get an equation for A PQ as omega square into R cos square lambda. So I will write therefore net acceleration at point P is G dash. This is equal to G minus of A PQ. So this is equal to G minus of A PQ is what? Omega square R into cos square lambda. Is it not? So omega square R cos square lambda. So this is the required equation. So I will write the final equation. G dash is equal to G, okay, minus omega square R cos square lambda. Final equation number 2. Now in equation 2 I am going to substitute the special cases by taking lambda at equator and the poles. So case 1 at equator. So what is the value of lambda at equator? That is equal to 0, because equator is 0 degree latitude. Therefore what is G dash is equal to G minus omega square R into cos square 0. So this is cos 0 whole square. Cos 0 is equal to 1, is it not? Therefore G dash is equal to G minus omega square into R. So it is less than G, is it not? Therefore here it takes a minimum value. The value of acceleration due to gravity will be minimum at equator. Now second one is at poles. At the poles lambda is equal to 90 degree. So cos lambda equal to cos 90 is equal to what? 0. So the second term will cancel. So I will write G dash is equal to G minus omega square R into 0. The second term will become 0. Therefore G dash is equal to G. Okay. And hence it is found to be maximum comparing to the equator. So at the equator the G will be minimum, and at the poles G will be maximum. So how did we start this derivation? I will recall once again. First you draw the diagram carefully. Understand the diagram. The mass M is kept at a point P. Its weight is acting along PO, that is mg. Okay, and when the earth is turning or rotating about an axis passing through the north and the south poles, this body of mass M will make one circular path and its radius is r dash. I am expressing r dash in terms of r. R dash is equal to r cos alpha. Understand that? And then I find that there is a centrifugal force acting on this mass along PS, because centrifugal force actually is a force acting on the body, actual body of mass M outwards, away from the center, along the radius r dash, Understand? And hence it should be mass into centrifugal acceleration. So we got an expression like this. And then this centrifugal acceleration which is acting along PS, I have represented here, omega square r into cos lambda. And this is resolved, its component is resolved along the direction PQ. Understand? So APQ is APS times cos lambda. So here you have to write again and again, then only you will understand. Afterwards, we find that G dash is G minus omega square into R cos square lambda. Then the special cases by taking lambda is equal to 0 for equator and lambda is equal to 90 for the poles. Only this area you should be very careful. Otherwise, it is very simple derivation only. I hope you must have understood well. Fine.